Okay, so we're given this chemical equation here, and basically what this and what any equation means really is that anytime we put in 2 moles of P2O5 and 6 moles of H2O, we're able to make 4 moles of H3PO4. So that's a really important thing to remember, is that these coefficients in front here refer exclusively to moles. This is 2 moles, 6 moles, and 4 moles. So this question here is asking, if we start with specific amounts of these compounds, which one is going to be limiting? And so what that means is if we put in 12 grams of this and 71 grams of this, which one is going to run out first? So the first thing that we're going to need to be able to do is to convert these grams into moles, because our recipe here is in terms of moles. So the way that you always convert between grams and moles is using this thing called a molar mass. So the molar mass of P2O5 is 284, and the molar mass of H2O is about 18. So this is essentially just a unit conversion. The way you do any unit conversion is that you start with the number that you're given, and then you multiply by a conversion factor. So we know that we're starting with 12 grams, and our conversion factor is that there are 284 grams in every 1 mole. So our unit that we started with always goes in the bottom. And the unit that we're trying to convert into always goes in the top of the fraction. So essentially what we're doing here is dividing 12 grams by the molar mass of the compound. And what we get when we do that is about 0.042 moles. So that's how many moles we have of the P2O5. Now we need to do the same thing for H2O using that molar mass. So we start with 71 grams, and we're going to multiply by 1 mole over 18 grams. And for that we get about 3.9 moles of the H2O. So now we know that we're plugging in 0.042 moles of P2O5 into our recipe and 3.9 moles of H2O. And it can be tempting to say, oh, well, there's a lot less P2O4, so obviously that's going to get used up first. But first we need to account for this ratio here, that we're not putting in 1 mole of this for every 1 mole of that. It's 2 moles of this for every 6 moles of that. And so what we can do now is we can pick either one of these starting materials. So let's say that we're going to start with our 3.9 moles, and we're going to say if I put in 3.9 moles of H2O, theoretically, how much P2O5 would I need to completely react with that? And this is pretty similar to the unit conversions that we just did, where you're going to multiply by a factor of 6 moles H2O to 2 moles P2O5. And what we find when we do that is that we need about 1.3 moles of P2O5 to completely react all of our H2O. Now, what we actually have here is only 0.042 moles. So since we have less of the P2O5 than we would ideally need, that's our limiting reactant.